So we are planning to discuss in the tutorial sheets also. Okay, so don't worry.
Is to-do
Fine.
about mentioned wrong in the notes?
Oh, I just forgot. But the last time I told you, see problem number 5 here. Problem number 5 says that for any set 2 to the power x denotes the set of all functions from x to 0, 1. This is what we try, like what I stated the last time, right? I stated last time. It was here, yeah. It was lecture 3, right? So this one was wrong. Okay, this part right here, it was wrong. The one in this cheat sheet now, part 5, it's correct. So I don't think there should be a problem now.
So, ma'am, one of my problem was in how, well, I mean, how much to write in a proof. So, for example, the first
Uh,
question can be done by using the second question. So, uh,
okay,
Yes,
so
ma'am.
because
should
the
I
problem
mention
is
the
proof
answer?
writing, आप कह रहे हैं कि आपसे समझ नहीं आता कितना लिखना है, तो आप प्रोजेक्ट कीजिए अपनी स्क्रीन. मैं अपनी स्क्रीन नहीं प्रोजेक्ट करती हूँ. आप मुझे दिखाइए कि एग्जैक्टली आप क्या लिखते हैं, ताकि मैं उसे जज कर सकूँ. कोई भी एक वॉलंटियर, थोड़ा बहुत कुछ. प्लीज शेयर.
Ma'am, in
Please share your screen. Some model answer which you think is correct, but you don't know whether the way of writing the proof is correct. But just kindly share. Okay. So hello Parth.
Yes, ma'am. So, this is the proof that I wrote. If it's
It's not
visible.
very clear to me. The visibility is low.
Ah,
I think Shraddha also projected. What is happening?
ma'am, I stopped it. Ma'am, I stopped it because Parth is sharing, so
Okay,
I stopped.
okay. So Parth, let's do one thing.
yes, ma'am.
Just share, take a picture of
Yes,
your
ma'am.
answer, clear picture, and share in the chat box.
Okay, ma'am.
From there, I'll try to project, because it seems that
Uh,
Hello.
yes, Shraddha.
Hello.
Yes.
Ma'am, I just want to share my approach for the first question. Sir, ma'am, I did it with the contradiction. Like real number is the union of rational and irrational. Suppose irrational is countable. So real rational plus I mean union irrational is real number, and countable union countable should be countable, but here real number is not countable. So what we suppose in the beginning that irrational is countable is wrong. So I did this way. Is this approach is right, or I should try another approach?
I think that's a very perfect approach. To me, it
Ma'am,
sounds
most of
great.
the question I truly don't
See,
know how to prove a question, so I use contradiction most of
Yeah,
the place.
same with me.
so it
Sorry, ma'am, I
doesn't.
can't hear.
Um, am I audible now?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so actually, what Shraddha was doing is, Shraddha was saying she has tried to approach the problem this way: R is equals to Q union Q complement. Suppose Q complement is countable, This will imply Q complement union Q is countable using the theorem dot dot dot, which says that countable union of countable sets is countable. Suppose QC is countable.
Yes, ma'am.
This implies R is countable. Right? But
Yes,
it
ma'am. And
is
it is
not
not.
true, therefore it's a contradiction.
Yes, ma'am. Ma'am, it's like 3 to 4 lines in the proving. So I
See,
thought it is not appropriate approach.
um, it is appropriate approach because see, you want to make an assumption, you want to prove something. You should clearly
Yes,
write
ma'am.
down the way you are approaching. Do you think there is any problem in this proof? What is the problem? There is no problem. You have assumed, you have like known that R is equals to something. From there,
Ma'am,
you try to approach the problem by stating a correct reason.
ma'am,
Yeah.
Yes, ma'am.
here
Yes,
we
ma'am.
are
Yes.
supposing Q is countable. Then we have to
Uh,
prove Q is countable, ma'am.
okay. Suppose, uh, yeah.
Rational is countable.
So again, now you see irrationals are countable and the real numbers is uncountable.
Yes, ma'am. And
I'm saying.
rational is countable.
So you need to state the fact. Yeah, that's one problem. Sorry. So
Mm,
if you see that's a 4-line proof, and if you think that there should be more written, you can
yes, ma'am.
you can just actually say that suppose Q complement is countable, right?
Yes, ma'am.
So we know that Q is countable.
Yes, ma'am. Ma'am, it is the statement.
You can anyways say that since f from Q to n given by something, like you can just use the fact that Q is countable for the
Yes,
time being.
ma'am. I used
Okay,
it as a fact.
you use it as a fact, then
So here
state
we,
it,
ma'am,
then state it. Okay,
here
if you
we
are
need not to prove that Q is countable. So we can only state it and it's done.
well now there is a catch. Suppose I am now stating that we know that Q is countable and R is uncountable. This is a contradiction since you need to write this is a contradiction. This symbol is for contradiction. This is a contradiction since R is uncountable. So you
Yes,
see
ma'am.
you are inherently using two facts here, this one and this one, and this one is
Yes,
a
ma'am.
theorem.
Yes,
So
ma'am.
you see if this is a question of say 5 marks, so
Yes,
do
ma'am.
you think that this much reasoning is like sort
Not
of
at
correct?
all, ma'am.
No,
Not at all.
no, right? So then you will have to show these facts, this one and
Yes,
this
ma'am.
one,
Yes, ma'am.
because this is a
Okay, ma'am.
theorem. If you are using a theorem which is mentioned already in the notes, see, it's an online exam sort of platform. So we will not
Yes,
ask
ma'am.
you to just prove the theorem.
Yes, ma'am.
If you are using the theorem that's like well detailed solved in the notes, then you need not mention its proof. But if you are
Yes, ma'am.
using some other things,
Yes,
prove
ma'am.
that. Okay. So it
Okay, ma'am.
depends how much marks it is.
Yes,
These
ma'am.
2 points should be proved.
Ma'am, if it is
Ma'am,
2 marks and 3 marks, then this much is sufficient. Hello?
Well,
Am I audible, ma'am?
yes, you are audible. If it is 2 marks, then I think that this much is sufficient because you will not have much time to write each and every
Yes, ma'am.
proof. Someone
Yes,
else
ma'am.
was
Ma'am,
asking something. Yes.
yes, ma'am. Ma'am, the theorem is countable. Union of countable sets is countable, no?
So
But
at
ma'am,
most countable
here,
union, at most countable. That
ha,
means if
okay,
we take finite union also,
okay, ma'am. So,
finite
ma'am, we
union of,
can alter the definition or the theorem, no?
so
According,
if I was to write this, I'll just write here that since finite, or I'll say at most countable union of at most countable sets is countable, is at most countable. Yeah, I'll just apply the word at most before countable in these three places. Okay.
Yes, ma'am.
So if you just write since finite union of countable sets is countable, then it's also true. You need not worry.
Okay, ma'am.
Okay, because the statement
Ma'am, in
which you
the
are using, is actually correct. It does make sense, complete sense. So it should not be like this, that if you just write this statement, you just don't write these statements and just write these statements. So if your proof just consists of this line and this line, then that's false. That should be 0.
yes, ma'am.
Because the reasoning which is required for you to understand that, and if you take countable sets, their union, either finite or countable union, then that is going to be countable.
Yes, ma'am.
Plus the facts that Q is countable and R is uncountable. So depending on how
Hello,
much,
ma'am.
yeah. Now
Ma'am, how to prove independently Q complement is uncountable?
Yes, ma'am.
independently means
Means not using Q.
It's
not
not using
using.
any theorems as a countable union, this or this.
Have you tried that one yourself? Please reply.
And also, I'm using this fact to just
Piyush, you are not clearly audible to me.
मैंने भी सेम ऐसे किया है एग्जैक्ट जैसे पार्थ ने किया है.
अच्छा, पार्थ ने सही किया
बट
है.
मैम ये सर मैं कहना चाह रहा हूँ कि इंडिपेंडेंटली मतलब ना तो क्यू का यूज करें ना तो आर का, सिर्फ क्यू कॉम्प्लीमेंट लें एंड प्रूव दैट क्यू कॉम्प्लीमेंट इज अनकाउंटेबल. हाउ टू प्रूव?
Okay, so I think I'll just write this one down and just come back to you in the tutorial session, and I'll ask Sirius to share the proof with you. Because currently I just don't remember line by line the proof. Is it fine?
Okay, ma'am.
Okay. So if I was to mark the question, then I'll just mark this right. But suppose it's a 5 marks question, so I'll just write here that some explanation is required. Q is a countable set. Suppose I just, if I am to say Q is countable, then I'll just say how. Okay, it's like how. I don't want that. Even if it's of 5 marks, if you can just say f from Q to N cross N, like some mapping, if you try to define from Q to N directly, then I'll not cut marks. If you just say here Q is countable, since some mapping from Q to N is bijection, I'll not want you to prove that it is a bijection. Do you understand?
Yes, ma'am.
How much, if a question is a subpart of another question, you do not need to explain everything of this subpart. You just write just the basic fact. Do not go into detail of this one, even when if it's of 5 marks.
मैम
Yes?
मैम कोई मतलब कि 1 1 ऑन 2 मैं बता दो क्यू कॉम्प्लीमेंट से आर में.
वही मैंने कहा बेटा कि वो जो 1 1 ऑन टू मैप Q कॉम्प्लीमेंट से R पे मैं आपको ट्यूट क्लास में शेयर करूंगी. ठीक है?
ओके, थैंक यू.
मैम सेकंड क्वेश्चन की आंसर कंस्ट्रक्ट हो जाएगा वैसे तो.
Ma'am, second question I have also done with contradiction, like fun.
See, it's you have done it with contradiction, but what is like appearing on your screen, given that A is countable and B is and sorry, A countable and A uncountable and B countable here.
Yes, ma'am.
So if you see, there is a some problem. I don't know what you wanted to prove in this one. So what do you want to prove?
I wanted to
Ma'am,
prove.
this
मैम
is
ये मैम कंट्राडिक्शन मेथड से नहीं हुआ, ये कंसिस्टेंट मेथड से हुआ है.
So we did not use this notation cardinality here. Uh, did I said anywhere cardinality? Did I use this symbol anywhere?
No, ma'am.
Yeah. So the next thing I want to mention is you do not have to go through things which we have not introduced. For example, there is a term like continuum hypothesis in the Eliprantis-Birkinshaw book. It's good if you look at them, but we will assume that you will not use them to prove here, because whatever we will give you, they should be easy to follow from whatever is done in the class. Okay, so this term
ma'am,
is
can I
actually
share
wrong.
my idea?
Yes, you can share your idea, but I'm pretty sure it should be like this. Suppose not, suppose.
No, ma'am,
What
it
is the
is not
question?
like it.
Sorry. What is the
Ma'am,
question? I'll just see the question first. Yeah.
yes, ma'am. Ma'am, I haven't done like that. Ma'am, hello, am I
Yes, yes.
audible?
Yes, you're
Ma'am,
audible. Please continue.
ma'am, it is only already given that A is uncountable and B is countable. So we have to prove that A minus B is uncountable. I have supposed that A minus B is countable. I have supposed. Then I have taken the union of A minus B and union B. Then it will be A, which is uncountable. But if I suppose that A minus B is countable, then the A minus B union B means countable union countable should be countable. But we are getting A which is uncountable. So here is the contradiction. Ma'am,
Uh, yes, I understood. So if you actually, if you want to say that two sets are equivalent, that means there is a bijection from set 1 to set 2. Okay, what you are
yes, ma'am.
proving is exactly correct, that this proves that A minus B is going to be uncountable. This proves that. But in order to prove that these two sets are equivalent, you need to form a bijection. Bijection from
Yes.
A to A minus B, uh, which is exactly done in this one, this proof.
Okay.
Okay, there is
Yes, ma'am.
actually a bijection.
Yes, ma'am.
मैम एम्प्टी सेट काउंटेबल होता है या अनकाउंटेबल?
Empty set should be considered a finite set, so that means an at most countable set.
मैम सभी फाइनाइट सेट काउंटेबल होंगे ना, तो उस पे
सभी फाइनाइट सेट हमारी टर्मिनोलॉजी के हिसाब से एट मोस्ट काउंटेबल होंगे. ठीक है, हम यहाँ पे काउंटेबल उनको बोल रहे हैं जो n के साथ बाइजेक्शन रखते हैं, मतलब सारे नेचुरल नंबर के साथ काउंटेबल ही इनफाइनाइट. तो फाइनाइट जो होगा या एम्प्टी भी होगा, हम उसे कहेंगे एट मोस्ट काउंटेबल. ठीक है.
ठीक है
Ma'am, this proving is correct. Ma'am, which is that showing in the screen.
Okay, I have not read this. I did stopped here. Sorry.
Okay.
Suppose A is
Yes, ma'am.
countable. So Parth, will you just explain what is done? What you were trying to say? I have crossed it, but it
So,
does
ma'am,
make sense, some
basically,
sense.
So A is an uncountable set and B is a countable subset of A.
Exactly.
So I took another subset of A which is countable. I called it C. So the thing is that C union B and B both are countable. So there would exist a
Yes.
bijection from C union B to C, and that's a mistake on my part. मैंने C union B से B पे bijection ले लिया. It should be from C union B to C. Uh, so uh, so essentially, I took A minus B, a bijection from A to A minus B such that all the parts which are not in B union C go to simply B because go to simply C because they have a bijection between them, and the rest of the set I simply took the identity the identity function which goes from A minus B to A minus B, and so there's a bijection from A to A minus B because of that, if that makes sense.
I'm sorry. How is it a bijection?
So ma'am, C union B and B would have a bijection because they are both countable sets.
Very good.
So essentially, A would be written as A minus C union B, union C union B. एक मिनट मुझको देखना पड़ेगा. Yeah, so A can be written as A minus C union B, union C union B. And I cannot explain it actually.
No, you are
Ma'am,
correct, Parth.
Yes, I know. I just I'm having trouble explaining it. Can I use a diagram if it's
Yeah,
possible?
it will be wonderful. I'll just
Ma'am,
stop this one.
yes, wait a minute.
Hello. One question.
Yes,
Why
Dheeraj.
F is a bijection? Because if you take a finite set, means two finite set, union two, means C is finite set, B is finite set, then A union B is finite set. So means if suppose we have a finite set M of element M and finite set of element N. Is there any bijection between?
नहीं धीरज एक्चुअली मतलब नोट्स के अकॉर्डिंग हमारे पास काउंटेबल वो होगा जो काउंटेबल इनफाइनाइट होगा. हम फाइनाइट सेट को काउंटेबल नहीं एटमोस्ट काउंटेबल बोल रहे हैं.
ओके,
ठीक है. तो यहाँ पे ये जो कहना चाह रहे हैं, ये कहना चाह रहे हैं कि ये काउंटेबल है तो वो इक्विवेलेंट होंगे और बाइजेक्शन होगा. तो यहाँ पे इनको ये लिखने की बजाय ये लिखना चाहिए था क्योंकि ये काउंटेबल है तो सी यूनियन बी से एन में एक बाइजेक्शन मिलेगा से एफ और बी से एन में बाइजेक्शन मिलेगा से जी. सो एफ कॉम्पोजिशन जी इनवर्स एक बाइजेक्शन मिलेगा सी आई गेस बी पता नहीं मतलब कुछ कंपोज करके हो जाएगा बाइजेक्शन मिल जाएगा. इनके कहने का तरीका वो नहीं है, बस हम उसी को जज नहीं कर रहे हैं, अब उससे आगे प्रोसीड कर रहे हैं कि अब उससे बाइजेक्शन कहाँ से मिला. अनिकेत प्लीज विल यू जस्ट stop sharing like because yeah.
Ma'am.
One thing also, Dheeraj, you see what happened?
Hello.
Earlier, they were asking in question number 1. I think I'll share the screen again. They were asking in question number 1, like how much to write in a proof. So what I said to them was,
if it is short, small number of questions.
yeah, you see this proof, proof 1. So proof 1, what are your comments?
But the argument is wrong. Means R is uncountable, Q is countable. Therefore, R minus Q is countable. So it is wrong. The statement is correct, but procedure is wrong.
Oh, yes. This one, I didn't realize it. I'm sorry, Parth. I thought that it was following the same lines as I told you in this part.
No, I used the second part to prove the first question. That A is uncountable, B is countable, therefore A minus B would be uncountable.
Okay, so
And then I gave the proof for the second part. So that's what I was asking. That should I mention this?
so if you are using some other problem, then I think you should just mention that I am using the second part.
Okay, ma'am.
Okay, so you should mention here it follows from question number dot dot dot. Okay, it
Ma'am,
follows
Okay, ma'am.
from something that. Okay. So the next question. Yeah, please explain.
So ma'am, essentially B is a countable subset of A and C is another countable subset of A. So if we
Okay.
draw a bijection from A to A minus B, we can see that there is a bijection from B union C to C because B union C is also countable and C is also countable. So there would exist a map from B union C to C, which I called F. Secondly, there would exist a map from A minus B minus C, which is on the left side, and the A minus B minus C on the right side. And that would be just the identity map because they are the same sets. So I just defined the function as F if A belongs to B union C and simply A if A belongs to A minus B union C.
Part one more doubt question. You take C is a subset of A, C is not equal to B. Okay. So that means if you take one element does not belongs to B, that is not equal to. Means suppose B contains some element X. So if you not include that X in C, so that means C is not equal to B. So that does not mean that C also include the other element of B. Okay. So
But does it? Because ultimately the property that we are using is both C and B are countable. So
No, Parth.
no,
Parth, listen.
Section to be empty.
He's saying that if it is A minus B, this set is A minus B. If something, if C intersection B is not empty, then this is not A minus B. You
so I
understand?
am saying that
You want
phi.
some set. You want to consider this C set from A minus B.
Okay.
Dheeraj is correct. Just try to
So
understand again.
from here that you see that phi of A equal to f of A. So f of A is a range space in C. Okay. So C also includes some element in B. You understand what I'm saying?
Yes, yes.
Yes, sir. Yes, sir. Sir,
Yes.
because of the bijection, C will have some element of B, na?
Because of
No.
construction, C is not equal to B. So it may also include some element of B. By bijection, it also includes some element of B if we consider C contains some element of B.
Okay. Sir, I have one more query. May I? Sir, all countable sets having any kind of bijection to another countable sets?
You mean
Yes.
countably infinite? Because I
Sorry.
am
Yes.
countable set, I
Yes,
also
Dheeraj.
remember finite set and
no,
infinite
Dheeraj.
set. So both are
Now our countable is countably infinite, Dheeraj.
Ma'am, about that, uncountable simply means not countable. So power set of n and power set of n both would be uncountable, but they won't have a bijection between them.
Power set is you are talking about finite power set.
No, power set of n, which is
natural
also
number.
Okay,
yeah.
and natural number, infinite.
So that's uncountable, and power set of n is also uncountable, but they won't have a bijection between them.
Do you understand now, Shraddha? You were trying to prove that a minus b is uncountable, but that does not imply that they have a bijection. Do you
Yes, ma'am.
understand now why
Yes,
the
ma'am.
proof was wrong?
Yes, ma'am.
Ma'am,
I
okay,
proved it
but
uncountable, but I haven't proved it is equivalent to a.
Okay, so someone else was saying something.
मैम वो जो बता रही थी वो अनकाउंटेबल है, वो उसका सबसेट है ना, तो जो भी होगा उसका कॉन्टिनम से तो कम ही होगा, मतलब कॉन्टिनम या फिर उसके उसके कम, तो वो वाला तो लॉजिक यहाँ पे यूज नहीं होना चाहिए।
लॉजिक यूज नहीं होना चाहिए, बट आपके पास एक प्रॉपर फिर प्रूफ नहीं, आप समझ रहे हैं। अब वही बात है कि आप जो प्रूफ करना चाह रहे हैं, जो नॉलेज आपको ऑलरेडी प्रोवाइडेड है उसके थ्रू करना चाहिए, ठीक है।
यस
जो
मैम,
पॉइंट मतलब अभी फिलहाल पॉइंट आप लोगों का यही है ना कि प्रूफ में कैसा लिखना चाहिए। तो अब आपने ये देख लिया, मैं आपको दोबारा समझाती हूँ इस पार्ट 2 में हुआ क्या। इस पार्ट 2 में हुआ ये कि हमें what happened in this part 2 was that we wanted to show a is equivalent to a minus b, right? And we
Yes,
were
ma'am.
given that a is a countable subset, a is uncountable, and b is countable subset. So we the proof path was saying was actually say 90% correct, but his choice of c was wrong. Now I'll try to explain it to you what he was doing. This is a set A and we are taking its subset A minus B. We need to find a map. Okay, so we need to deal with this B part here. I want to make a bijection from A to A minus B. So what will happen to B? So not now what he was doing is he was trying to take something C which is also countable. Okay, C which is also countable, but C is not equals to B. So the correct choice of word should be here that C intersection B is equals to empty. And why such a choice is available? Such a choice is available. So why such a choice is available?
Because A is uncountable.
Because A minus B is uncountable.
Yes, ma'am.
Okay, and we know
Yes,
that every infinite set has a countable subset, and
yes, ma'am.
we know that every infinite set has a countable subset. Okay, just please fill in the statements. So if we choose such way, now please just let me finish. If I choose C such that C is from A minus B, you see the colors are not matching, so that means they are disjoint. So now
Yes,
I can map this C minus B to just C. And this is an equivalent mapping. This mapping is equivalent. Rest all I'm mapping to itself. No change.
Yes. Yes,
So
ma'am.
phi of A will be f of A for A belongs to C minus B. Okay.
Yes.
So if what happens? Yeah. So this mapping is nothing but this mapping. For anything to from this happens. And if I'm choosing elements from B minus C, it should be the function bijection. This one. Okay.
Yes, ma'am.
So is it clear now that is a bijection?
मैम इस क्वेश्चन को एक बार प्रॉपर्ली स्टार्टिंग से समझा दीजिए ना।
properly starting से फिर से समझाती हूँ, रुकिए. What we want to create a bijection between a and a minus b. That's clear. I
Yes, ma'am.
want to create a bijection between a and a minus b. This is what I want. So to create a bijection, I wanted this bijection. You see, a to a minus b, there is a complete loss of b. So I need to deal with the loss of b. So I want to create a map so that this b does not create trouble. So I will take something from a minus b which is countable. I am taking something from a minus b which is countable. I am just short of colors now. So I am taking something from a minus b which is countable. This part is countable. And why I'm choosing it countable? Because I know b is countable. Countable union of countable sets is countable. So this complete set will have a bijection with this small set. So that is the
Yes,
way I
ma'am.
have dealt with b. Okay. So anything that is in C
Yes, ma'am.
union B, I'll map it to just C. Because I have already a bijection between them. Okay. So now what you do, you try to write the proof. Okay. I've explained the idea. You try to write this proof. You just mail it to me or Dheeraj to let it to check it. If there are any further problems with your proof, we will correct it and send it to you. Okay.
Ma'am, one more
Ma'am,
query. May I?
ma'am,
Yes.
I have a doubt.
There are 3 people.
Yes, ma'am.
Shraddha,
Yes, ma'am.
Sapna, and one more person.
Yes, ma'am.
Please, one by one,
May I?
ask. Okay,
May I, ma'am?
Shraddha, yes.
Ma'am, previously, Parth has also said that all countable set has no bijection with another countable. Here, how can we say that?
Yes. Parth was saying that no, like if we have uncountable sets, then the bijection would be a trouble. But if we have countable sets, all countable sets are equivalent and equivalent to natural numbers. Okay.
Ma'am, here we are saying now that there is an bijection with C union B to A minus B minus C. Ma'am, how can we say this bijection?
No. I am saying that there is a bijection from
Yes, ma'am.
from C union B to B.
Ma'am, how
C,
could we
C,
To
say
C,
this?
C.
C.
That will be C.
To C. Yeah. I did a lot of errors.
Ma'am, how we say this? Ma'am,
Because
what is
both of them are
reason?
countable, because B is equivalent to N and C union B is also equivalent to N. Why? Because they are both countable. So if they are equivalent, there will be a map from N to B and G from N to C union B, which both are bijection. So if I try to see the map, say
Yes,
G
ma'am.
inverse composition with F, then that will be
Yes.
a bijection from C union B to B.
Okay, ma'am. So the
Okay.
correct statement is that if two countable sets are equivalent, then they have bijection.
Any two countable sets are equivalent.
So they have
By
bijection.
this reasoning, yeah. Equivalent means that there is a bijection.
Okay, ma'am.
Okay, by this above reasoning, any two countable sets are equivalent.
Yes, ma'am.
Ma-
Okay,
Now it is
ma'am,
clear.
now yes,
ma'am,
Bilal. First of
ma'am,
all, let Sapna speak, please. She was waiting. Yes, Sapna.
ma'am, I have a doubt in the proof existence of a choice that
Sap-
implies
Sapna,
existence of
your
a choice
voice is not clear.
function. Ma'am, now is it clear?
I'll try to understand. Please say.
Ma'am, I have a doubt in the proof that existence of a choice set implies existence of a choice function.
Can you just type it in the chat box, Sapna?
Okay, ma'am.
It is getting difficult for me to understand. Now, Bilal, meanwhile, please ask.
Ma'am, myself Rohit, it was Rohit, ma'am.
Okay,
Ma'am, my
Rohit.
question, ma'am,
Rohit, sorry to just
ma'am,
confuse.
my question was that, ma'am, you have used the condition that why such is available, a minus b is uncountable. The black
Yeah,
color one,
yeah, yeah,
ma'am.
yeah. I understood.
Ma'am, how can you say like that?
Okay.
And you have said that we are not using continuum hypothesis. Then how can you say like that?
See, I don't know continuum hypothesis for now because I have not taught you.
Oh.
And I don't remember because it's been years since I read that. Okay. So what I'm trying to say is from the notes.
Hello?
Yes, Rohit, I am saying that my reasoning will be from the notes. If that's fine with you. Is that fine, Rohit? At least say yes or no. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. You
Yes,
are
ma'am.
audible.
Okay, so I'll just take a clean slate. Fine.
मैम
So
क्वेश्चन नंबर 2 के लिए हम सिर्फ एग्जांपल दे के भी बता सकते हैं क्या, मतलब प्रूफ देने की जरूरत ना हो अगर?
नहीं, no. When you have to prove something, you must give a proof. Okay. When you have to disprove something, only then you will give a counter example. So let me write what is happening. Oh my, the battery died in the pencil. Just wait. Okay, Sapna had a doubt in the proof of existence of choice set implies existence of choice function. Okay, we will see that. Okay, so first of all, let's clear Rohit's doubt. So A was uncountable and B is given to be a subset of A and that too countable. I am saying that my claim is that there exists C subset of A, C intersection B is equals to phi, that means disjoint, such that C is countable. Everyone agrees that this is what we were trying to say? Rohit?
Yes, ma'am.
For the time being, I'll want Rohit to reply.
Ma'am,
Yes.
ma'am, from my side, there is a network issue, ma'am. There may be weak means.
Okay, so I'll just keep on going. So I wanted to, what I was saying that why such a set was available, because there exists, this is my claim that there will exist a subset of A such that C intersection B is phi. This means that C is contained in A minus B. Just to make it clear. So why so? See, A is countable and B is uncountable. Sorry, A is uncountable and B is countable. That these two statements will imply that A minus B is uncountable.
Yes, ma'am.
Since otherwise, by the theorem that countable union of countable sets is countable, there will be a contradiction. Okay?
Yes.
Because it is countable, we also know that any infinite set has a countable subset.
Yes, ma'am.
This we have done in the class. So this implies there will exist a countable subset C of A minus B. Is it fine now? If you have further doubts, then you can ask again in Rohit, or you can just mail me. Okay, so now
Yes,
I
ma'am.
want to move on to Sapna's query, which was from existence of choice set to choice function. What we did was we just take tuples. We took tuples. I'll just repeat what we did. We took tuples yi xi with I, then yi were non-empty because xi's were non-empty, plus they will be pairwise disjoint, right? So if because they are pairwise disjoint, so we will have a choice set, right? We will have a choice set. That means E will be
Yes,
contained
ma'am.
in union of yi, and E intersection yi will be singleton. I am just writing that singleton to be xi with I. So if I map every I to this xi, then that will be a well-defined function because E intersection yi is a singleton. I will not be mapped to two different quantities. Well-defined means that one point is mapped to just one point, and it is happening here. So what is the problem here, Sapna? Which part? I think there is a network issue from Sapna's side also. That's why her voice was shaky. Okay, Sapna, if just mail me again what was your doubt. I'll move on to forward. Another question. Any other question? See, again, you wanted to understand
Ma'am,
what is the correct way
Ma'am,
of writing a proof. So I am saying if your
ma'am,
proof has a, just please wait a second. If your proof has a correct amount of reasoning, then that will be well and good. You see the way Parth has written, he has written like in a very readable manner. That means I am trying to like prove something that this is equivalent and I have given something. Okay. He has used some terminologies, some missing points were there, but it is completely readable. You do not skip. According to him, there was no missed reasoning, but we proved that there was missed reasoning. Sorry. So that's what we want. We do not want you to jump any reasoning. How that happens? Question mark. Okay. And actually, it will be more clear to you if you just try to write some proof yourselves and get it checked. That is the best way. Like practice makes someone perfect. Without writing, you will not understand what is wrong in this proof. Okay. Now, please, one by one again, you were saying something. So Jatin said how well ordering principle implies PMI. So Jatin, well ordering
yes,
principle.
ma'am. I have done PMI implies well ordering principle, but I'm not getting how to do well ordering principle implies PMI.
I think well ordering principle implies PMI. We had done this part. I didn't prove the other way. Yeah. So I am saying that well ordering principle implies PMI. So I just proved it by contradiction. Suppose PMI says what? That if we have a subset S of n, if we have a subset S of n such that one is there, and if someone is there, its successor is there. That means if n is in S, n plus 1 is in S. So I wanted to prove that S is equals to n, right? This is what I wanted to prove. So I suppose that S is not equals to n. Then what? Then n minus S will be non-empty, right?
Yes, ma'am.
N minus S, I am saying that it is T. So T by well ordering principle, we will have a least element. That means there will exist an element L such that L is less than equals to T for all T.
Yes, ma'am.
Okay. So there is a like missed place, missed reasoning in this proof actually. That means also L is not L is strictly greater than 1. Why?
Yes, yes.
Because
Because
It
one
is
belongs to
subsidiary.
S.
1 is in S already,
Yes, ma'am.
and T L belongs to T which is n minus S. So L cannot be equals to 1. Therefore L minus 1 this implies L minus 1 will all actually belongs to N. That will be a natural number. Okay. A natural number which is not in T will be in S.
Yes, ma'am.
So this reasoning was missed. If that created trouble for you, then I'm sorry. So because the least element is not equals to 1, so L minus 1 will be in S. If L minus 1 is in S, then by this part, L minus 1 plus 1 should be in S.
Yes, ma'am.
That means L is in S, but it is not possible because L was
Yes, ma'am.
in the complement. So therefore a contradiction.
Thank you, ma'am.
मैम मैम इस प्रूफ में वेल ऑर्डरिंग प्रिंसिपल का यूज हुआ है, इसलिए ये इम्प्लाई कर रहा है क्या पीएमआई को?
हाँ जी, प्रूफ में हम यही चाह रहे हैं प्रूफ करना कि वेल ऑर्डरिंग प्रिंसिपल से हम पीएमआई को डिड्यूस कर सकते हैं. We can deduce PMI from well ordering principle. Yes, Harsh.
Then can we show that axiom of choice is equivalent to PMI?
They are both equivalent. We very well know, but actually I have not read any proof, to be honest. I didn't felt the need, but if you are interested, you can go on and just read some proof. Definitely they are equivalent, but I don't know the proof.
Ma'am, I didn't get any proof on Google.
Because it's not
Me
just
too.
simple. It's not simple. Okay? It is not simple. I'll just try to look at it then. Are you satisfied, Harsh?
Okay, ma'am.
Anyone else?
Ma'am, can you please tell the approach of question 4 and 5, or you will discuss on tutorial?
That will discuss in the tutorials. Okay, don't worry.
Okay, ma'am. Ma'am, actually, I was not able to find any kind of approach in these two questions.
We will see. We will see. Don't worry. So Sapna is saying something. See, choice set. Why we use choice set? Because we want to define a map. A function will be well defined only we map one element to just one element. We can't map one element to too many elements. That will not be a function. You know, by the very definition of a function, it should be a one thing cannot map to two different things. And to define a well-defined function, we have used choice set because choice set was such that it had only one element. Okay. The part where we have used choice that we want choice set because we want the function to be well defined. Suppose suppose E intersection x yi was something that xi and xi tilde I. So if I'm defining I to xi, then it can happen that I can choose I have two choices for I then. That would be trouble. Do you understand, Sapna? We can say xi's are distinct because E intersection yi is a singleton set. It cannot have many points. It's just one element.
Ma'am,
Yes, Sarthak?
how do we show that the digits after the decimal point are countable? Do you get it?
No, it's not countable.
I mean, ma'am, a digit after a decimal corresponds to a negative power of 10. So, ma'am, we can take a bijection. I mean, that's what I thought.
No, it's not a bijection. You try to think. If not, then I'll supply a proof. Just mail it to me
This
that
fact has been used to prove that 0, 1, the interval 0, 1 is uncountable.
interval 0, 1 is uncountable because we have a power
And
10
we list
expansion of
out
everything.
we list out the array of elements, and we consider a number to be 0.d1, d2, and if we are enumerating them, that means they are countable.
They are not countable, Sarthak. They are not
Not,
countable.
no,
I
ma'am.
can.
No. I'm
They,
asking. Let us consider a decimal number.
yes.
So the digits after a decimal, they are countable or uncountable? Let us suppose
See the digits after something. You can see count them. First place, second place, third place, nth place,
so
and
they are
so
countable.
on. So the number of digits. If you are saying that the
No,
number of
I'm not.
digits is countable, but the number which is forming from the digit, that is uncountable.
Number of digits we are forming are uncountable, but the digits after a decimal, they are countable.
The number of digits
Yes,
are
ma'am.
countable, but the number which is formed from the digits is their collection is uncountable. So Rohit wanted to ask that what is the order of topics that will happen in the course. See, I honestly don't know. Okay, so sir will take the class tomorrow, and you can ask the question to him. Okay, he is the correct authority to answer that.
Yes.
So the proof of PMI implies well ordering principle. I think the time is running. I'll just uh, um, explain it in the tutorial session, if that's fine, Anshul.
Yes. Yeah.
Ma'am, for the
Please.
third question,
Third question
can
in
we
the cheat sheet.
can we yes, ma'am. Can we say that this is equivalent? Well, the set 0, 1 is equivalent to the number of functions from natural numbers to 0, 10, the 0, 9, the integers.
See, as long as you are like proving by using something, and whatever you are using is justified, whatever you are using is justified, it's all fine. But for a safer side, just if you have such a proof in mind and you are not sure it is correct or not, just mail it to me.
Okay, ma'am.
It will always be better if you mail. Okay.
Yes,
and
ma'am.
and I'll actually reply within say 12 hours or 24 hours. I'll not delay more than that for any of your mails. Okay. Any other doubts?
No, ma'am.
Okay, so should we end this?
Ma'am, further question we will discuss on tutorial.
About the Q cheat questions, we'll discuss in the tutorials. Any other questions?
No, ma'am.
Okay, so summary is that you wanted to understand how to write a proof. So the easiest way is to just do something and send it to me. I'll write everything that this particular reasoning is missing, the structure is wrong or right. Okay. If you just do something wrong, only then you will understand what is the value of doing the right thing. Okay. We actually and discussed for the two questions from the TU sheet, and nothing important else was done in the session. So I have concluded this. So please stop the meeting, stop the recording now.
Yes, ma'am.
Thank you, ma'am.